So in this video, we're going to evaluate a definite integral that involves natural exponential functions. So here we have the definite integral from 0 to 1 of e to the x over 1 plus twice e to the x, and this is dx. And what we want to recognize is that the derivative of the denominator, 1 plus 2e to the x, is almost what we have in the numerator. In fact, the numerator differs from the derivative of the denominator by only a constant. So this is a case where a u-substitution is one technique that could be employed and should work. So we could let u equal the 1 plus 2e to the x that we see in the denominator. And if we do that, and then take the derivative of both sides with respect to x, we'll get du dx equals the derivative of 1 is 0. We get 0 plus, and the derivative of 2e to the x is just 2e to the x. And then by algebra, we get that 1/2 du is just equal to e to the x dx. So now I can come over and do some substitutions. I can replace the 1 plus 2e to the x in the denominator with u, and I'm going to have the e to the x dx getting replaced with 1/2 a du. So the 1/2 is a constant. So I'm just going to get 1 over u du. And then I look at the definite integral and I see that x is running over the closed interval from 0 to 1. So if I make the substitution u equals 1 plus 2e to the x, that means that u is going to run over the closed interval from 1 plus 2e to the x, but x will be equal to 0, comma, 1 plus 2e to the x, but at this bound it's going to be e to the 1. And then I can simplify these just a hair. 1 plus 2 times e to the 0 is 3, because e to the 0 is 1, so it's 1 plus 2 times 1 is just 3, comma, and this is 1 plus 2e. So I'm going to change my bounds of integration from 0 to 1 as I move from the x-coordinate system into a u-coordinate system. So 1 plus twice e. And now I have a 1 over u, and I know the antiderivative of 1 over u is just going to be the natural log of u, running from 3 to 1 plus 2 times e. I don't need the absolute value sign in this particular case, because over the closed interval from 3 to 1 plus twice e, these numbers are all positive, so I'm not worried about putting a negative sign into the natural log function on accident. And then we can plug in our upper bound of integration into the log function, so we get the natural log of 1 plus 2 times e, minus, plug in the lower bound of integration, the natural log of 3. And now I have the two natural logs separated by a minus sign, so I know I can combine that into a single natural logarithm, 1 plus 2e divided by 3, using our natural log properties.